What's up, guys? Welcome to the explanations for the Chapter 6 test. Let's do it. All right, question 1. The table shows how many students are in each grade of a school. Express each ratio as a fraction in simplest form, no mixed numbers. So we want the ratio of 9th graders to 10th graders, which is 9th is 20, and we always give it in the order that it's given. So 20 over 10th grade, which is 24, and then we reduce that by dividing the top and bottom by 4. And we get 5 over 6. That's our ratio. 5 over 6. All right, question number 2. The table shows, so it's the same thing, and now we want a ratio of 9th to 11th grade. So we take the number for 9th, which is 20, over the number for 11th, which is 38. We can reduce by dividing the top and bottom by 2, and we get 10 over 19, like that. All right, question number 3. We have 12th to 10th grade. Notice the order. We're doing 12th first, which is 28, over 10th grade, which is 24. The top and bottom can again be divided by 4, and we get 7 over 6. All right, that's all we're doing for fraction reduction. 7 over 6. And last one, 11th to 12th grade. So 11th is 38 over 12th, which is 28. And we divide the top and bottom by 2, and we get 19 over 14. And there's our answer. Okay. Next, express as a unit rate spending $36 for 6 t-shirts. And there's always a question on what's the order? What do we divide by what? Well, look at the answers. It's all dollars per t-shirt. Whatever comes after the per, that's what we're dividing by. So we're doing 36 divided by 6, which is just 6. So the answer is $6 per t-shirt, and that makes sense. If each one is $6 and we're buying 6 of them, it should be 36. So $6 per t-shirt. Next, we're trying to find meters per second if you look at the answers. So we got meters, 126 per second, which is 14. And now we just divide, and I believe 14 goes in that 9 times. So it's 9 meters per second. And this just happened to reduce exactly. This is actually the same as 63 per 7. It's just not fully reduced. So 9 meters per second. So now it looks like we're doing again dollars per hat. So it's $84 per hat over 21. And 21 goes into 84 4 times. So we got $4 per each one hat. All right, question number 8. What is the cost per ounce of 16-ounce bottle sold for $2.40? Cost per ounce, right? So what does that mean? We're doing the dollar divided by the number of ounces, which is 16. So let's actually figure that out down here. 2.4 divided by 16. That is 1 times 16. 24 minus 16 is 8. Bring down to 0. 16 goes into 85 times with no remainder. So we've got 15 cents per ounce. Question number 9, complete the conversion. 20 feet is how many meters? And we know that 1 meter is 3.28 feet. Well, here's how we set one of these up. It's very important because I think a lot of times people know we take that conversion, we multiply or divide, but the question is, what do we do? So we start with our original value of feet, and we want to convert it to meters. The way I like to do it is I always then multiply it by a conversion fraction or a conversion proportion. And what that means is we want the same unit on the bottom that we're starting with, and then the unit that we're transitioning to on the top, because it's just like we cross off similar numbers on top and bottom of these cross these multiplication of fractions, we can also cross off the units when one unit's on the top and one's on the bottom. So we have feet here and feet here. We'll be able to cross them off and we'll be left with meters. But now the onus is on us to create a ratio that is equal, because the only way to do this is if we multiply any quantity. To keep the quantity the same, we have to only multiply by 1. So meaning, if these two values are equal, this will be effectively equal to 1, and that's allowed. So what I mean is, since I know that 1 meter equals 3.28 feet, because these two values are equal, meaning 3.28 feet is equal to 1 meter, this quantity is really 1, so it's okay to multiply it by this because we're not changing anything. The feet then cancel out, and we see then as we multiply across, we get 20 over 3.28. This is a division problem. This means we're doing 20 divided by 3.28. And even if that may have been your instinct, now we know for sure that that's correct. So I'm just moving the decimal over to do my division. We can never divide with a decimal in the divisor. 328 goes into 2006 times 1800, 1920, 1968. And then we get 32, bring down a 0. Make sure that dot's on top. This goes in 0 times, right? Doesn't fit. And then we add one more 0. And that goes in, I think, 9 times. So let's see, 2700. Yeah, I'm going to say 9. So there's something like that. So 6.09. And if we look, so rounded to the nearest tenth is going to be this guy, 6.1. Definitely not 6.7. Okay. Same idea, complete the conversion. 17 liters to gallons. So again, and my conversion proportion, I'm going to put in liters on the bottom, gallons on top. And we need to basically have, what do we have? We know that 3.79 liters equals 1 gallon. Liters cancels out, and that leaves us with 17 over 3.79, which means this is just a division problem. 3.79. We don't like decimals in the divisor, so we got to move those. Got to move these likewise, right? Whatever we move here, got to move here proportionately. 379 goes into 1700. 5, let's see, 5 times. Hold on. I got to do this quickly because I'm not totally sure. 35, 39, 3, 15, 18. That was too big. So it's going to be 4 times. 4, definitely. And let's do this like this. 36, 28, 31, 12, and 15. Cool. So 4 up here, and that's 15, 16, I believe it was. And this is 184. Bring down another 0. 379 goes into 1840. Yikes, 6. It's probably 5 times. 5 times is 15, 350. Oh no, that's too big. That's too big. It's 4 again. I already know that 4 times this is 15, 16. This becomes 4, 2, 3. And then this last one will be, it'll be like 8 maybe, something like that. But we know it'll be greater than 5. So for rounding purposes, it's probably going to round to 4.5. It looks like it's going to be this guy, 4.49. That's clearly our best option. And there we go. Okay, complete the conversion, round to the nearest hundredths. Again, 1 kilogram equals 2.2. So we're going 14 kilograms to pounds. Okay. So we've got, again, kilograms down here, pounds up here. And we need 1 kilogram is equivalent to 2.2 pounds. Again, these guys cancel out, multiply across. We got 28. 28. I'm trying to do this in my head, plus 2.8, 30.8. So it ends up becoming 30.8. And this is pretty nice because that just multiplies across. And we just got 30.8 over 1, or 30.8 pounds. And that should be our answer. Right here. This is clearly our best answer. Boom. Next, we've got 10 ounces equals how many grams? And again, I'm going to start with 10 ounces here over 1. Then we're converting to grams. So we got the ounces on the bottom, we got grams on top. And now how many grams? It's 28.35 grams equals 1 ounce. And then we multiply across. Oh yeah, cross off the units. 10 times 28.35 is 283.5. Just move the decimal 1 spot over 1. And that's it. 283.5 grams. All right, next question 13. John bought a 12-ounce drink for $2.50. How much would a gallon of the same drink cost? Okay, so this is a little different. We say $2.50, so this is dollars, over, what is it, 12 ounces. And we want to convert to gallons, all right? So we want the price per gallon. So now we don't want ounces on the bottom anymore. We want gallons on the bottom. So I'm gonna put my ounces on the top. So then these guys cross off. And then we want gallons on the bottom like this. All right, and then how many, what's the relationship? 1 gallon equals 128 fluid ounces. And now our ounces cancel out. And now we're gonna end up with dollars per gallon. So we multiply across, 128 times 250, let's see, 256 plus 64. I'm just doing that in my head really quickly. You could multiply it out yourself as well. 12, 1, 3, so it's 320. So it's $320 per 12 gallons, but we want per 1 gallon. So we just do that division problem and we will get it down to the unit rate. 320 divided by 12. Oops, 12 goes into 32 twice. Subtract, we get 80. 12 goes in to 86 times, that's 72. And then it's gonna be repeating. So $26.6 or $26.67 if we round it to the nearest hundredth. All right. Question 14, find the missing side. These two are similar, meaning the angles are all equal and there's a constant these sides are proportionate. So how do we do this? We just set up a proportion. This side is equivalent to 7, so we could do it like this. We could say 3 is related to 7. In the same way, therefore equal to, the same way that 2 should be related to x, right? The corresponding sides have a common proportionality. So you see how we have the 3 and the 2 both from the same figure on top, and the 7 and the x both from the same figure on the bottom. So there's some matching going on. And now we cross multiply. 3 times x equals 2 times 7. So 3x equals 14. Divide by 3, divide by 3. And we get x equals, if we reduce that, it's 4 2/3. Because 3 goes into 14 4 times with a remainder of 2. Question 15, what will be the y-coordinate of the top point of the triangle after a dilation of the triangle centered at the origin with a scale factor of 2? Meaning, all we're doing is we're taking the xy coordinate and the scale factor of 2 multiply by 2. So check this out. We've got a coordinate of 2, 4. We multiply that by 2. Let's use this symbol. So it goes there and there. And our new coordinate is 4, 8. That's it. Simple as that. And the y coordinate, which it's asking for, is 8. Done. Question 16. ABC has vertices 2, 5, 5, 9, 6, 1. Get the vertices after a dilation of 3. Same idea. We just take every coordinate and multiply it by 3. Boom, boom. And then so on and so forth. This becomes 6, 15. This becomes 3 times 5 is 15. 3 times 9 is 27. 3 times 6 is 18. And 3. And that's it. It's just a multiplication problem. Not too hard. You just got to know what you're doing. And that gives us this guy. Finally, question 17, convert 60 miles per hour, 60 miles per 1 hour to feet per second. So we got to convert this and this. So it doesn't matter the order. That's the beauty of it. Let's just knock off one at a time. So how do we convert miles to feet? Well, I'm going to put miles on the bottom, feet on top, right? To cross off the units. Then how many feet is in 1 mile? It gives us that number right there, 5280. Then these will cancel out. Then we got to convert the hours to seconds. So we know that I'm going to again put the hour up here so we can cancel it out. And let's first convert it to minutes and keep it easy. 1 hour we know is 60 minutes, right? And then again, convert those minutes to seconds. We know that 1 minute has 60 seconds. Now we cancel out the hours, minutes, and we will have feet per second. Simple as that. Now we can go ahead and multiply everything across and get our answer, but we could also simplify a little bit. I see a 60 on top, 60 on bottom. Those can go away. And now we just got 5,280 feet over 60 seconds. This is just a division problem, so let's divide it. 5280 divided by 60. 60 goes into 528 8 times. That's 480. And that's 48. Bring down that last zero. 60 goes into 488 times. And that's exact. No remainder. So 60 miles per hour, fun fact, is 88 feet per second. All right, that is it for the explanations for the Chapter 6 test. Time to move on to the next section.